3 is scientific measurements. We're going to talk about accuracy versus precision. And then hit Sig Figs, and then we'll finish 2.3 tomorrow. But I really want to get to Sig Figs. So first up, accuracy versus precision. So accuracy is how close you can get to the known value or to the target. So when we did our iron, sulfur, and salt lab, you guys measured out 5 grams of each substance and mixed it together, and then you were trying to extract the same exact 5 grams, and you measured your percent error, which was basically looking at how accurate you were. Precision is how close the measurements are to each other. So you do a lab, maybe you're doing like your water density lab, and you looked at all your values and you noticed that they were really, really close. And then I had a question on the lab that says, what do you based on your data, what was the density of water? Some of you said 0.99, or some of you said 1, or about 1. So that means that, using your measurements and your calculations, all your values were showing, hey, water's got a density of around 1 gram per centimeters cubed. So down here I have 3 dartboards displaying accuracy and precision, either high or low accuracy or high and low precision. So looking at this first dartboard, what would you say the accuracy is? Pretty good, high. And the precision? High. So we have high accuracy and precision. What about this dartboard? The accuracy?
Low accuracy, high precision.
Yep, and this one?
Low accuracy.
All right, so you guys get the drift. Okay, so we've done percent error before, but here they introduce it to chapter 2. So you take your value for your experimental minus the value of the actual divided by the actual times 100, and then you get a percent. So it says a student measures the mass and volume of a substance and calculates its density as 1.4 grams per milliliter. The correct or accepted value of the density is 1.3 grams per milliliter. What is the percent error? So we're gonna, set this up, right? So what was my value of the experimental?
1.4.
Yeah, 1.4. So I'm going to write 1.4 grams per milliliter minus the actual. What was the actual? Yep, 1.3. Grams per milliliter. Wow. Nice. Division sign there. Divided by 1.3. So the units will completely cancel on this, thus the percent error, like the percentage. Yep, so 1.4 minus 1.3 divided by 1.3 times 100, 7.7. %. Okay, so that's percent error. We've done that multiple times already in this class, and even in biology. Some more percent error. What is the percent error for a mass measurement of 17.7 grams, given that the correct value is 21.2? So we'll set it up. So we'll start with 17.7 grams minus the correct value of 21.2. Divided by 21.2 times 100. Did you guys get a negative value?
Negative 16.5.
Yep. So negative 16.5%, thereabouts. Okay, a volume is measured experimentally as 4.26 milliliters. What's the percent error given that the correct value is 4.1 milliliters?
2.7%.
Oh, all right, so I gotta set this up here.
What? 2.7.
Hold your horses, speed racer. So fast. Newman's hands are so fast you can type it into the calculator and blazing speed racer.
Okay, 4.26 minus 4. I know, but
feel like 16's already, yeah,
Whoops.
yeah.
Okay, so we already did the scientific measurements. That was the activity where you had to measure my classroom. Moving on to Sig Figs. Significant figures, that's what Sig Figs means. So, significant figures are, you know, when you do a math problem and all of a sudden you're like, geez, how many decimal places should I go to? Well, significant figures can answer that question for you. So it is a measurement that consists of all the digits known with certainty. So you know those are like digits that you should include in your measurement, plus one final digit that is usually uncertain or estimated. So there are some rules to determine which digits in a number are significant and which ones are not. Okay, so the first rule is the easiest rule. Non-zero digits are always significant. So if I have the number 27.3, all of these digits are significant. So if I ask how many significant digits are in this number, you would say 3. Okay? Or 3.1457, the beginning of pi. All of these are non-zero digits. They are all significant. How many sig figs do you have here? 5.
That's not five.
It's different.
3.141596.
Yeah.
Yeah.
Wait, what?
Oh,
It's just happens to be a happy coincidence.
Oh.
3.14.
my bad. Thank you. So it's not the beginning of pi. Okay, you scared. I thought like I really messed up. Okay, so it's just me. The notes are good. Okay. But yeah,
Some
1,
people
2,
it's
3, 4,
3.14.
5.
For engineers, it's 3.
Okay, the next 4 rules all apply to zeros. Okay, so zeros in between non-zero digits are significant. So you see this 0, it's sandwiched in between 2 non-zero digits. So therefore we count it as significant. So how many sig figs are in this number? 3. All these zeros are sandwiched between non-zero digits. So how many sig figs? 6. Okay, the third rule. Zeros in front of all non-zero digits are not significant. So these 3 zeros do not count, because technically I could get rid of them by using scientific notation.
Oh, that's.
Yeah.
Great.
Okay. So if you come across a number like this, there's only 4 significant digits, not 7. Okay. How many sig figs are in this number? 1. All these zeros do not count. Okay, now I know you said, oh, I could get rid of them with scientific notation. Here's the 4th rule that just really messes kids up. Zeros at the end and to the right of decimal, the decimal point here, are significant
What for?
because it shows you how accurate the measurement is.
I've been writing things as 85. Oh, God.
Yeah, so these 2 zeros at the end count because they are at the end of the number and there's a decimal point. If there's no decimal, then that leads me to rule 5. Okay, so this number 85.44 has 4 significant digits. Okay, what about this one?
All of them.
Is it?
Except for
Well,
the
do the
first
zeros
two.
in the front
The
count?
first,
2 don't count.
No, but these zeros do. So 1, 2, 3, 4, 5, 6, 7.
God, that one sucks. It's got
Okay, 5th one. Zeros at the end of a number with no decimal are not significant. So these zeros don't count.
So just a one.
So it's just 1 sig fig.
it could be 3
These
million
zeros
feet.
don't count.
It could be 3
One.
So if
million
there is
feet,
no
only
decimal,
the
they
first
don't
one
count.
starts.
Right. If there's a decimal, if I, plop a decimal there, then all 3 of them are significant.
I I need to get a tattoo of this to remember that.
Yeah, literally.
Oh, I added a short little 50-second TikTok video on Google Classroom. That's like 99.9% accurate. So if you're struggling, you just play that TikTok video, whatever you want to call it. It's on there. Hold on. Okay, so let's go through some examples.
I was just gonna say how many significant numbers was that?
There's three.
Three, right. So these don't count. There's three. I'm just gonna stick it on top. 4. That 0 is sandwiched, so it counts. 1. Yeah, these don't count. 3. There's that decimal. Sneaky.
Sucks.
2. These zeros do not count. Yep, that's easy. Yep, that 0 doesn't count.
Oh, that's a lot.
1, 2, 3, 4, 5, 6, 7. Yep, they're all non-zero. Okay.
7.
This 0 is significant because it's sandwiched, and then this is at the end past the decimal, so it's significant, so it's 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, and these 3 zeros are at the end of a number past the decimal, so 12.
Why is the 600 just? Oh, because
No decimal.
1, 2, 2.
2. Those don't count. 2. These 2 zeros do count because I put that little decimal there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, okay.
That's a lot.
Isn't this so much fun?
I love Sig Figs.
I mean, honestly, it's not that bad. But
Okay. Now, that's just looking at a number. Okay, that's just looking at a number. Now we're going to do some calculations. Okay? So, rules of Sig Figs and calculations. In multiplication and division, the answer cannot have more Sig Figs than the smallest measurement. So here we have two numbers, we're multiplying it.
you can only have 4 significants.
Right, so you figure out how many sig figs are in this number. You go 1, 2, 3, 4, 5. There's 5 sig figs here. And then over here there's 4. So your answer has to have 4 sig figs. So you'd punch it in your calculator, 12.257 times 1.162. And I get a really, really, really long number here. So actually, never mind. I just got my pen, so I'm just going to go with it. I'm writing it all out. Hold on here. Okay, so my answer has to go to 4 sig figs. So I go 1, 2, 3, 4. Okay, and I'm just going to like draw a little line to show that. And I look at the last digit, and I ask myself, hey, can I round up on this 4? No. So your answer is just going to be 14.24. So multiplication is pretty simple. What's your unit? Meters squared. Meters times meters is meters squared. All right, so 46.3. We have 3 sig figs, and this is just 1. So your answer is going to be 1. So or has 1 sig fig. So 46.3 times 2, I get 92.6. All right, and now I can only go 1 sig fig, right? So it's just going to be 9D. I need a 0 there for that place value. If you put 9, you're wrong. I mean, 9 is not close to 92. So your answer is going to be 90. So I got 1 sig fig. That 0 doesn't count. And then what's your unit? Yep, centimeters squared.
This just sounds more inaccurate.
Yeah, it does.
That's the way it is. Well, that 2 is inaccurate.
Who made this?
I don't know. Okay.
Oh no.
Let's look at addition and subtraction. These are worse.
Holy.
I think they're worse.
Sigmund.
Okay, so the top one's going to be the smallest.
All right, so the answer cannot have more digits to the right of the decimal point than the measurement with the smallest sig figs. So what I'd like to do, I like to line them all up, okay, and then I just like draw a line where they last had, where they all had the last number place. I'm totally saying that wrong. Okay, so then you just like do the math. So 3.95 plus 2.879 plus 213.6. All right, so I get 2, 2, 0.429. Okay, so this is what I'm going to write, but I got to look at this last digit. Can I round up on the 4? No. So your answer is 220.4 grams.
That sucks.
Okay, now it's actually not that bad though.
No, it's not. It's just tedious. Okay, so same thing. Line them all up. Look at the last place they have in common, and then do the math, and then see if you got a round. 0.95.
Thanks, Abby. Right there.
Oh God, this is so bad. Okay, so this is the last place. I look at the digit. After it, can I round up? Yeah, so your answer is going to be 215.18 grams.
When I subtraction, see how the 3.95 is like the smallest one up there?
Two Sig Figs.
So you just draw that line
Yeah.
behind it?
Oh, so it doesn't have to be 3. Like 3 Sig Figs? 'Cause like,
No.
That's wrong on that one.
Okay.
This one's only gonna have 2.
Mr. Squidward.
Oh, 7.
No. All right, so I'm going to do the math first. 5,400 plus 365. 5765.
So I thought it was an 800?
Okay.
So that's normal. What?
Oh, no, wait.
There's no decimal.
There's no decimal. Never mind. Hold on. Let me get my eraser.
35, dude. You dumb.
It just...
That's the best.
dumb. So dumb. All right. I don't know why I drew that line. I was like, oh, zeros. They're not significant. Yeah, so the decimal is...
So it's a whole thing?
Yeah, I think you just leave it.
Really?
I don't know. Actually, I don't know.
There's no
There's no decimal.
58. Oh, yeah, okay. That's right. Okay.
No, 50. Number 9.
The answer cannot have more digits to the right of the decimal point than the measurement of the Sig Figs. Guys, I really don't know.
Well, if anything, you
It's either 5,800 or you just leave it.
Just leave it, I say.
I almost feel like it should be 5,800 because those zeros are not significant.
where's the that's what
Oh, I mean, if it had a decimal, it would be.
Bring in a Sig Fig calculator.
But it doesn't have a decimal, maybe.
I know, I'm saying. I said if it did, it would. You'd have to count them.
All right. Well, maybe the TikTok video can help us. Let me pull that up.
Yeah. First
Tic
ever
Tac.
TikTok series.
chemistry TikTok. On my 40.
All right. Oh, gotta turn on my speakers here.
Oh my god, I've seen this.
It worked 99.9% of the time. 0.
This is the best way to do
Okay, let's see if we figure out the answer.
Hi everybody. This is for all of you people out there that don't know how to do Sig Figs, and I don't know why. So I'm gonna help you out with this rule we learned.
Famous. What are you doing? This is huge.
So when you have a decimal point, you start counting at the left. When there's a 0, you don't count the 0. So this one would have 3 Sig Figs.
What?
This number, dot left. So we start at the left. 1, 2, zeros. So this one has 2 Sig Figs because there's 2 regular numbers. Over here, dot left. Start at the left. 1, 2, 3, 4. There's not a dot, so we start at the right. There's 2. Not a dot, we start at the right, but there's 2 zeros here, so we go here. 2 Sig Figs.
Favorite hole in one.
I hope this helps.
So basically that
That didn't help us.
that last one,
What?
they cut the zeros off.
They cut the zeros off.
True.
Yeah, that's why I want to say it was 5,800. That's why I feel like it should be 5,800. That's why I drew that line in my brain, but we're just going to say it's 5,800.
We're making everything 100.
We looked up the-
I don't know if that video helped you. So
No, not.
okay.
Not really.
Okay, so your assignment, I got paper copies, but there's actually 2 of them. One is calculations, and one is just like, hey, how many sig figs are in this number?
0.
And I just have to think about where I place
Right,
the
it's supposed to be
assignment.
like right
I'm gonna
now.
stop videotaping.
Minion.
They're doing picture things like right now, aren't they?
Oh no.
How many significant figures are in your name?
Okay.